In a previous section, we learned about the idea of direct variation. Okay, so when we decided to talk about direct variation before, we could always say y varies directly as x, or we might have phrased it as y is directly proportional to x. That always followed the equation y equals kx. We're putting kind of a twist on that now. If we say that something varies directly as the nth power of x, then instead of having y equals kx, we're going to have y equals k times x to the nth power. And you'll notice this pattern right here, kx to the n, is just another choice of letters for ax to the b. So that's why we're putting this with power functions. These are indeed examples of power functions here. And the whole process that we learned for solving direct variation, where we solve for k, and then plug in our variables to find the answer at the end, is going to apply here. But now I want you to think every time you read a word problem with variation, or you could say proportionality, you want to look to see what kind of variation you have. So on the table are not just direct variation, but also now direct variation as the nth power, or, in just a second, inverse variation. So let's look at this example and see how I could tell if this is direct variation or direct variation as the nth power. So it says, suppose the weight of a ball of lead varies directly as the cube of the radius of the ball. So let's go ahead and stop right there. Varies directly. Okay, that tells me it's going to be one of those two things. So is it normal old vanilla direct variation, or is it varying directly as the nth power? If we keep reading, it'll say as the cube of the radius. Okay, so notice it doesn't actually say the phrase nth power. Instead, that is a specific power. That is the third power. Okay, so because we read it carefully, we notice this is direct variation as the nth power. So in other words, as the cube, the third power. So when I set this up, it's going to be y equals k times x to the n. But hey, I actually already know that n equals 3 for this problem, because it is the cube. Okay, so we want to be on the lookout for those special words like the square or cube, those special power words. Okay, so we've got that set up. Let's go ahead and plug in the things we have here. So radius of 2 weighs 380 grams. So we need to decide if we're dealing, well, which variable is y, basically. So the pattern is always y comes first, and it varies directly as the nth power of x, which comes second. Okay, so the way they phrased it, the weight is y, and the radius is x. So in this example, they've told us that the radius is 2 when the weight is 380, so a weight of 380 equals k times, and then x, which is the radius, is 2. So let's see, 380 equals 8k. So I will divide both sides by 8. So let's see, that's 190, 95, 47.5. Okay, so I found k. The next thing I'm supposed to do, just like direct variation that we saw before, is go back to my equation, except this time I know what k is. So I'm writing it as 47.5 x to the 3. And now let's fill in the thing that they're asking about. They asked me what would be the weight if the radius, in other words, if x is 5. So let's let the calculator help with this. I'm going to do 47.5 times 5 to the third power. Comes out to 5937.5. Now let's be careful with the final answer here. Okay, the units I'm supposed to use for weight in this problem are grams. So this is 5937.5 grams, or you could say 5.9375 kilograms even, if you wanted to convert it that way. Okay, so the process was exactly the same as what we saw for kind of just vanilla original direct variation, but now we have this nth power to consider as well. Okay, one last thing to add on here, there is another type of variation we might see, called inverse variation. So if we ever say that y varies inversely as x, or you could say y is inversely proportional to x, then instead of having the equation y equals kx, we're going to have y equals k divided by x. Okay, so that's the big difference. Direct variation means multiply. Inverse variation means we're going to divide by x. Okay, we can also have kind of this same spin for as the nth power. We could say that y is inversely proportional to the nth power of x. Or maybe y varies inversely as the nth power of x. So just like we can have an nth power in direct variation, we can also have an nth power in inverse variation. As far as the process for solving these, you set it up, you find k, and you put things in your final equation. Okay, so that part should be familiar. I would much rather just learn these by doing some examples in the homework. They're not super different from what we've already seen. Okay, so now anytime you see a problem that talks about variation or proportion, look for a few things. One, is it direct or inverse? And number two, do I have some word that indicates a certain power, like squared or cubed or the fifth power? Okay, so always be on the lookout for those things so we can choose the right equation to model it. Either y equals kx to the n, y equals k over x, or y equals k over x to the n.